If the world were to end, we naturally expect it to be loud. Sirens blaring, meteors crashing, or a blinding flash of light. But the removal of every trace of our world would begin in absolute silence. It would start as a tiny, almost invisible patch in the deep night sky, where nothing seems to be happening at all. Astronomers would eventually notice that a specific cluster of distant stars looks wrong. Instead of sharp points, their light would smear and stretch into strange glowing rings, as if you were looking at them through the bottom of a glass. This diagram shows a process called gravitational lensing. When a massive object sits between us and a distant star, it literally bends the fabric of space. The starlight traveling toward us gets caught in that warp, curving around the unseen mass before it reaches our eyes. This gravitational signature is the only warning of the approaching mass. Because it emits no light of its own, the distortion of space is the only way we can track its movement through the dark. We often picture black holes as cosmic vacuum cleaners, aggressively sucking up everything in their path. But they actually behave like incredibly heavy objects moving through space, exerting a powerful, outward-reaching gravitational pull on anything they get close to. This diagram shows the solar system's standard orbits as that external gravity well approaches from the edge. Over time, the gravitational balance starts to break down. The planets drift slightly off course, their paths stretching and shifting, while comets are pulled into entirely new trajectories. The precise mechanical rhythm that has kept our solar neighborhood stable for billions of years would fall out of tune. A silent, massive force is on a direct path for Earth. Up in the sky, those shifting orbits might seem like abstract astronomy problems. Under that immense strain, that immense gravitational influence reaches the surface of our planet. This cross-section illustrates extreme differential gravity. Thick arrows show the near side experiencing a severely stronger pull than the far side. These forces act on the planet's solid mass, pulling the rocky crust upward just as the moon pulls the sea. Under that immense strain, continents fracture, global earthquakes ripple across every landmass, dormant volcanoes awaken, and entire coastlines buckle and surge upward against gravity. If you were to look up through the chaos, the cause would finally be visible. A perfect, sharp circle of absolute darkness would dominate the sky, acting like a hole in reality that entirely erases the stars behind it. Framing that sheer black void is the accretion disk. It is a superheated, blindingly bright ring of dust, gas, and broken planetary matter spiraling inward. As the material falls, friction heats it to temperatures hotter than a star. The planet is systematically fracturing from the inside out. Above it sits a sky that is both blindingly radiant and unnaturally, perfectly dark. Eventually, the remnants of our planet cross a boundary known as the event horizon. There is no physical line in space to mark it, but once crossed, escape is mathematically impossible for anything. Not for rockets, not for debris, and not even for light itself. To an outside observer, everything on Earth appears to slow down more and more as it approaches the black hole. Light becomes redder, dimmer, stretched. Eventually, Earth seems to freeze at the edge, never quite crossing it. Yet for anyone still clinging to the surface, the experience is completely different. The local clock keeps ticking normally. There is no dramatic pause, no slowing of reality, just a continuous, uninterrupted freefall into the dark. Falling deeper into that immense gravity field, the difference in pull between the top of the planet and the bottom magnifies drastically, bringing the physical destruction to its peak. This animation demonstrates spaghettification. As the sphere descends, extreme forces stretch it vertically while crushing it horizontally, pulling it into a long, thin stream. Oceans, mountains, the core, and every atom are drawn apart into a continuous flow of cosmic matter. Nothing survives crossing this threshold. The physical structure of matter and the flow of time are disassembled by the gravity field. With the planet entirely consumed, that stream of atomic matter plunges past the visible edge of the universe, falling relentlessly toward the very center of the black hole. Waiting at the core is the singularity. This is a solitary point in space where all the consumed matter is crushed down until its density becomes mathematically infinite. At this precise point, every equation and theory we have for physics simply fails. Space, time, and the ideas of before and after cease to exist as functional concepts. But if we zoom out and return our perspective to the safe, distant reaches of space, the view is entirely different. Out here, the black hole remains exactly as it was. It is perfectly stable, slowly warping the starlight around it, operating in complete silence without a single visible sign of the destruction that just occurred. The entire mass of our planet, every record of its history, and every trace of life has been absorbed. It contributes slightly to the black hole's overall gravity, but leaves no signal behind. The universe does not require loud, explosive drama to be terrifying. Gravity alone, doing exactly what gravity does, is enough to systematically dismantle a world. It proves that an entire planet is merely a fleeting, silent moment in the path of unstoppable cosmic forces.